What is the average value of y, pause, average value of a function, they're giving us the function right here, average value of a function, starting to process things within a new context. Average value of a function, we need an integral, we need to divide by the width of the interval, for the part of the curve in the first quadrant. This curve right here. Well, what? All right, we're gonna pretend like we can't use the calculator. So I'll grab my calculator, set it aside, and I won't tell you when I'm actually using it during the video. I'm kidding, I won't. We can graph this by hand, and that's kind of the point, and we can do this one by hand as well. So we don't need a calculator. So just to prove it to you, here we go. Stay right there. Casting a shadow there, we'll leave it there. What I really want to do is know what this graph looks like, and I can get a visual for it. Good way to graph is to find x-intercepts. So let's just start with that. So if 4x equals 0, then x would equal 0. This can happen in your head. 2 minus x equals 0, x equals 2. What we just did was set the factors equal to 0. You've done this before. So 0, 1, 2. We know that we have x-intercepts here and here. And we know that we have an upside down parabola. Parabola because it's squared. If you were to take this a little bit further, bring it up here, you would have 8x minus 4x squared. So you have a parabola that's upside down, and it has those two x-intercepts. Sorry, that one is a y-intercept. And it goes like this. How high up do you go? Who cares? Who cares? Do I really care how high it goes? No, I need a visual, because what I really need is the average value of y, which will give me, well, let's switch colors, purple. That was a quick decision. The average value is going to be 1 over the width of the interval and the area from 0 to 2 of 4x times 2 minus x, sorry. So 8x minus 4x squared, and then dx. So this is my average value right here. This is the average value. Call it f of x, or f of c if you want to. They didn't define this as f, so I'm just going to leave it like this. This is going to be my average value. So we're going to do this one by hand, and the calculator will stay right there. I promise I won't move it. No, I'm kidding. I'm not kidding that. I promise I won't move it. We're going to take the antiderivative of this thing, which would be 4x squared, and 4/3 x cubed, from 0 to 2. It's going to get really easy, actually. Plugging in 0 into these is going to just make them cancel. So fundamental theorem of calculus means plug in the 2, crank out an answer, plug in the 0, crank out an answer, subtract. Plugging in 0 gives you 0, so y? So 1/2, let's just plug in the 2. So 2 squared minus 4/3 times 2 cubed, and that's going to give us 1/2 times 16 minus 8 times 4, 32 over 3. 32 over 3. If this was free response, you can leave your answer exactly like that. Like, just stop right here and be like, well, we're done. And you would have a lot less room for computational error, unless they said, now use your answer for the last part to figure out well, you'd need to know it then. But if they said, compute the answer, you're done. Like, within the last few years, they have started to say, just don't go any further. You've got the idea, computational mistakes can happen. So this is where you could leave it. I'm going to keep going because I feel like it, because I would just hate to not know what it is. And it will be 1/2 times, oh goodness, let's not do it that way. Let's do it a different way. I'm going to go ahead and distribute my 1/2. I think it's going to make my life a little easier. 8 minus 16/3. And then we get a common denominator of 3. And so that would be 24, and then that'd be 8/3. That's it.